Good morning, everyone. I'm here to discuss engineering data analysis. And our topic for today is all about Chapter 10 Simple Linear Regression and Correlation. Regression refers to the statistical technique of modeling the relationship between variables. In simple linear regression, we model the relationship between two variables. One of the variables denoted by y is called dependent variable and the other is denoted by x is called independent variable. The model will be used to depict relationship between x and y will be straight line relationship. A graphical sketch of pairs x and y is called scattered plot. Empirical model. Many problems in engineering and science involve exploring the relationship between two or more variables. Regression analysis is a statistical technique that is very useful for these types of problems. For example, in a chemical process, suppose that the yields of the product is related to the process operating temperature. Regression analysis can be used to build a model to depict yields at the given level. So here's the example data of our empirical model and the example plot of this table. The scattered plot locates pair of observation of advertising expenditures on the x-axis and sales on the y-axis. Based on this figure, we notice that larger or smaller values of sale tends to be associated with larger or smaller values advertising. The scattered point tends to be distributed around positively sloped straight line. The pairs of values for advertising expenditures and sales are not located exactly on a straight line. The scattered plot reveals a more or less strong tendency rather than the precise linear relationship. The line represents the nature of the relation on average. The population simple linear regression model. Y is equals to beta sub 0 plus beta sub 1 x plus e, which is beta sub 0 plus beta sub 1 is non-random or systematic components, and our e here is random components, where y is the dependent variable, the variable we wish to explain or predict, and our x is the independent variable, also called the predict variable, and our e is the error term, the only random components in model, and thus the only source of randomness in y. Beta sub 0 is the interpret of systematic component of regression relationship. And lastly, beta sub 1 is the slope of systematic component. The next one is correlation. A correlation exists between two variables when one of them is related to the other in some way. As a scattered plot is the best place to start. A scattered plot or scattered diagram is a graph of the paired x and y sample data with a horizontal x-axis and a vertical y-axis. Each individual x and y pair is plotted as a single point. The correlation between two random variables x and y is a measure of the degree of linear association between the two variables. The population correlation denoted by P can take on the value from -1 to 1. P is equals to -1. It indicates a pair of negative linear relationship. -1 less than P less than 0. It indicates a negative linear relationship. P is equals to 0. It indicates no linear relationship. 0 less than P less than 1. It indicates a positive linear relationship. And lastly, P is equals to 1. It indicates a perfect positive linear relationship. The absolute value of P, it indicates a covariance of two random variables x and y, where covariance, the quantity of x and y, is equals to E, and x minus mu x, the quantity minus mu sub y, where mu sub x and mu sub y are the population mean of x and y respectively. So here's the formula of the population correlation coefficient. P is equals to covariance, the quantity of x and y, all over the sigma sub x and sigma sub y. The sample correlation coefficient. R is equal to the sum of square x and y all over the square root of sum square of x and sum square of y. So here's the example. Tapos ginamit natin yung formula natin sa correlation coefficient. Yung thank you.